Video 8. Is solar electricity right for you? Before you invest your hard-earned money in a solar electric system, it is important to determine whether a solar electric system makes sense for you. Will a PV system meet your needs? That's right, will a PV system meet your needs? How much will it cost? Would you be better off using utility power, or would some other type of renewable energy system make more sense for you? And even if it doesn't make perfect sense economically, what about the environmental benefits and personal gratification of doing the right thing? What about alternatives to buying your own PV system, in particular leases and power purchase agreements? In this video, I'll help you answer these questions. Assessing the electrical demand. The cost of a solar electric system depends on many factors, among them the size of the system, the complexity of the system, the distance the installer must travel, the type of installation, and the difficulty of the installation. Because solar resources and electrical consumption vary, most residential solar electric systems fall within the 1 to 6 kilowatt range, most common being the 3 to 6 kilowatt system. In an all-electric home equipped with a wide assortment of electrical appliances such as central air conditioners, electric space heaters, electric water heaters, and electric stoves, average monthly electricity consumption typically falls within the 2000 to 3000 kilowatt hours per month range. Even in sunny climates, a large PV system would be required to meet electrical demands, systems in the order of 10 kilowatt systems. In homes in which natural gas or propane is used to cook food, heat water, and provide space heat, electrical consumption may be as low as 400 to 500 kilowatt hour per month. A smaller system would be needed in such instances. Although many factors affect the cost of a PV system, the size of the system depends on electrical consumption and solar resources. How you go about calculating consumption depends on whether it is existing in structure or one that's about to be built. Let's begin with existing structures. Assessing electrical demand in existing structures. Assessing the electrical consumption of an existing home or business is fairly easy. Most people obtain this information from their monthly electricity bill going back 2 to 3 years. If you don't save your electrical bills, a call to the local power company will usually yield the information you need. Some customers can access the data online to the utilities company website. All you need is a customer number. If you purchased a home that's been around for a while, you can obtain the energy data from the previous owner. Remember, however, a house does not consume electricity, its occupants does, and we all use energy differently. If a previous homeowner and his or her family used energy wastefully, their energy consumption data may not be of value to you. Assessing electrical demand in existing structures. To determine the total annual electrical consumption from utility bills, don't look at the cost in dollars and cents. Look instead for the kilowatt hours of electricity consumed each month. Calculate the total for each year and then calculate a yearly average. If you are considering installing a grid-tied electric system, a PV system that feeds surplus electricity back to the grid, the annual electrical demand is often all you need. You can size your system based on this information. If you're thinking about serving your ties with the utility, that is, taking your house off the grid, you will need to calculate monthly averages as well. That is, how much electricity is used on average each month. To do this, add up household electrical consumption for each month and then divide by the number of years worth of data you have. For example, if your records go back 4 years, add the electrical consumption for all 4 Januaries and then divide by 4. Do the same for February and each of the remaining months. This will help you to determine when the electrical demand is the greatest. Off-grid systems are sized to meet demands during the times of the highest consumption. After you have calculated energy consumption, take a few moments to look for trends in energy use. Is energy consumption on the rise, or is it staying constant or declining? If energy use is rising, you should dump earlier years' data. It doesn't reflect your current consumption. If you don't, you will end up undersizing your system. Assessing electrical demand in new buildings. Determining the monthly electrical consumption is fairly straightforward in existing homes and buildings, and determining electrical demand in a new home, or one that's just been built, or one that is about to be built, is much more difficult. One method used to estimate electrical consumption is to base it on electrical consumption of your existing home or business. If, for instance, you are building a brand new home that's the same size as your current home, and the new home will have the same amenities and the same number of occupants, then the electrical consumption could be similar to your existing home. If, however, you are building a more energy efficient home and installing energy efficient lighting and appliances, and installing passive solar heating and cooling system, all of which I highly recommend, then the electrical consumption could be easily 50 to perhaps 70% lower than in your current home. If that's the case, you can adjust electrical demand to reflect the efficiency upgrades. Another way to estimate electrical consumption is to perform a load analysis. A load analysis is an estimate of the electrical consumption based on the number of electronic devices in a home, their average daily use and energy consumption. To perform a load analysis, a homeowner begins by listing all the appliances, lights and electronic devices in his or her new home. To keep track of all the loads, I recommend using an Excel worksheet. It can be found online. Plug-in watt-hour meters. Power meters are useful for estimating load and also for gaining an appreciation for the energy demands of household appliances. Knowing which appliances and devices are the energy hogs in a home may empower occupants to reduce the energy consumption. Surveying the energy use. Surveying the energy use of a household appliance could be a great educational project for children. Once you've prepared a complete list of all the devices that consume electricity, your next assignment is to determine how much electricity each one uses. This can be done by referring to the name plate on the back side of each electronic device. It lists the wattage or sometimes just the amps. To determine the watts, multiply amps by 120 volts. You can also determine consumption by directly measuring each device with watt meter. After you determine the wattage of each electrical device and light, you must estimate the number of hours each one is used on an average day, and how many days each device is used during a typical week. From this information, you calculate the weekly energy consumption of all devices in your home or business. You then divide this number by 7 to determine the average daily consumption of your home or business in watt hours. You will use this information to determine the size of your PV system. Load analysis may seem simple at the first glance, but it has several problems. One problem with load analysis is that many electronic devices draw power when they are off. Such devices are known as phantom loads. They include LED TVs, satellite receivers, cell phones, laptops, computer chargers, and a host of other common household devices. A few, like the satellite receivers, draw much power when they are off and when they are on. Phantom loads typically account to 5 to 10% of the monthly electrical consumption in US homes. If they are not factored into the load analysis, estimates can be off. Once you've calculated daily energy use, the next step is to find ways to reduce the energy. Reducing energy demand. This reduces the size of the electric system you'll need to install. The smaller the system, the less you'll spend and install on your system. So how much can you save? Every dollar invested in energy efficiency saves $3 to $5 in cost of a solar electric system. For instance, if you invest $2,000 in measures that trim the electrical energy use in your home or office, for instance by sealing leaks, adding insulation, and installing more efficient lighting, you could save $6,000 to $10,000 on the cost of a solar electric system. Because efficiency is both economically and environmentally superior to increasing the capacity of a renewable energy system, most reputable solar installers recommend energy conservation and energy efficiency measures first. If you agree to pursue these measures, they downsize your system and save you thousands of dollars. Solar installers may make specific recommendations. Solar assessors do the same. In fact, they are trained to offer objective third-party advice on efficiency and solar system requirements. Another option is to hire a home energy auditor. A qualified home energy auditor will perform a more thorough analysis of your home and make recommendations on ways you can reduce your demand. They will prioritize energy saving measures for homes.